Solving trigonometric equations using fundamental identities. So in this case, we're going to limit x to be between 0 and 2 pi for all of our angle solutions here. And in all honesty, this is a difficult looking problem from the beginning. We have single angles inside of cosine, double angles inside of cosine, single inside of sine, and double inside of sine, as well as some constant on the other side. So as I get going, I don't like both double and single angles hanging out in the same problem. So the first thing I'm going to do is go ahead and use a double angle formula. Actually, two different double angle formulas. I'm going to replace the cosine of 2x with cosine squared minus sine squared. Definitely not the only way to go through this. As long as you're using these identities, you're going to be okay as you work on these. Just follow the identities. Some directions go differently than others. Some are more precise and more quicker solutions, but just stick to the identities as you go through these. I'm using the version for cosine of 2x that goes cosine squared minus sine squared. I also want to replace in sine of 2x. In this case, I'm going to go ahead and use the version that says sine of 2x is 2 sine of x times cosine of x. All right, from here, maybe a little distributing, clear out these parentheses, go ahead and multiply this sine of x to the inside, get rid of that set of parentheses. So as I do that, I'm going to go ahead and say cosine cubed of x, cosine of x times cosine squared of x, minus, now you can put these in whichever order you want. I'm going to put the sine squared first, times cosine of x. But this cosine of x got distributed and a copy got multiplied by the sine squared of x. Okay, next I'm going to clear out this other set of parentheses by saying sine of x needs to be multiplied by this other sine of x. But because everything's multiplied together, that's just going to be 2 sine squared of x times cosine of x equals square root of 3 over 2. You may have noticed that I put this cosine of x after the sine squared here. The reason for that was I wanted us to very visually see this term, this middle term, and this last term are going to be like terms. They each have a sine squared of x multiplied by cosine of x. So these are like terms. We can combine these together. So at this point, we have cosine cubed of x, and then we have 2 sine squared of x times cosine of x, minus 1 sine squared of x times cosine of x. That's going to leave us with positive 1 sine squared of x times cosine of x. Looks kind of complicated with sines and cosines, but really we have 2 of these. We're subtracting away 1 of the same thing. Just combine them together and got positive 1 sine squared of x times cosine of x. All right, now in solving this down, I realize a lot of people would move that square root of 3 over 2 to the left-hand side and think about factoring. Instead, I'm just going to kind of rely on looking at the left-hand side and saying to myself, these both have a cosine of x. Let's factor out a common factor first. So if we pull out a cosine of x, what's going to be left inside a big set of parentheses is going to be cosine squared of x plus sine squared of x. All right, just a common factor, removing that from each one of those terms on the left-hand side. But now look what is inside our parentheses. We have cosine squared of x plus sine squared of x. That fits in really nicely, and you hopefully get comfortable with this whenever you have squares. Be thinking about the Pythagorean identity. All right, so the Pythagorean identity says sine squared plus cosine squared is equal to 1. So I can replace everything inside this big set of parentheses with 1 based on the Pythagorean identity. So really where we're at here is we have cosine of x equals the square root of 3 over 2. Well, square root of 3 over 2 is one of these values that comes up quite often as far as ratios go. Hopefully at this point, we're comfortable that if we were to plug in pi over 6 into cosine, then that would produce square root of 3 over 2 in a positive case. All right, so that's going to be one of our solutions. We also want to be a little bit careful here. We may have more than just one solution. So how I remind myself of this is this phrase, all students take calculus. All of our ratios are positive in the first quadrant. That's where this pi over 6 is located. That would be the angle in the first quadrant. Then when you plug it into cosine, we'll give this ratio. But we could also use this as a reference angle, the pi over 6, in other quadrants. And hopefully we can find the one that would produce a positive square root of 3 over 2. Now, how all students take calculus works is all of them are positive in the first quadrant. Only sine is going to produce a positive ratio in the second quadrant, only tangent in the third quadrant, and only cosine in the fourth quadrant. Now, because our cosine is equal to a positive ratio, that's pointing us towards this fourth quadrant where cosine is always positive. What I'm going to do is I'm going to place pi over 6, that angle we just got, as a reference angle here in the fourth quadrant. And we want to calculate what angle wraps all the way around into the fourth quadrant that's going to have pi over 6 as a reference angle. And those are always drawn to the x-axis. Hopefully we recall. Well, to do that calculation, we know all the way around is going to be 2 pi. But we want to back up and not go all the way around. We want to go pi over 6 short of that. So our other angle can be computed as 2 pi minus pi over 6, or equivalently, we could say that's 12 pi over 6 is equivalent to our 2 pi minus pi over 6. I just rewrote that, so we had a common denominator. 2 pi is equivalent to 12 pi over 6. And now combining these over that common denominator, we can say that's 11 pi over 6. That's going to be our angle that wraps into the fourth quadrant that has pi over 6 as a reference angle. That's going to be our other solution. So we did end up with 2 solutions here for this equation. So I hope this helps out. I know this was a kind of challenging one using both a double angle formula and the Pythagorean identity along the way to get to something that we're more comfortable with, like cosine of x equals square root of 3 over 2. Hopefully the reference angle business made sense and putting that in the fourth quadrant. Good luck as you're working on these.